All right, so we're here with our honor stats class, period 2, getting ready to go over the multiple choice review questions. We're going to go straight through 1 through 10, and I'll be referencing to the board on the side to go over how we're doing as a class. All right, so the first one. The chirps from cricket. It says, what is the estimated increase in temperature that corresponds to an increase in 5 chirps per minute? Well, if you look at this, it says X is the number of chirps per minute. Okay? So if I look at my slope of 3.3, all right? My slope of 3.3, if I interpret it, says, for every increase in 1 chirp per minute, what do I expect to happen to the increase in temperature? To go up by 3.3. But this doesn't say for an increase in 1 chirp per minute. It says for an increase in 5 chirps per minute. So you take that 3.3 and you multiply it by 5. And that's it. B. All right, so Team LFKC SPWM is off to a commanding lead. 1-0. So I'm not sure why you're not.
Because he's in our team. So every time we get one right, I'll wrap it up.
I want you to be writing down the work on your paper. Okay. What's the problem? Are you guys focused on this? Hold on. You guys talking about this?
Yeah.
This means the values that you plug in are supposed to be greater than 9, but less than 25. But this problem has nothing to do with it. If you wanted to, you could do this. Here, you could do this. You could have plugged in 10. Watch this. Could have plugged in 10, because that is greater than 9, but less than 25. And then what's 10 plus 5? You could have plugged in 15. And if you compare those, right, if you subtract those answers when you get that, you get 16.5. Okay. Number 2. It gives us the scatter plot. I know it's kind of hard to see the dots up here. All right, and it gives us the equation for the regression line. And it asks about a residual. So immediately when I say residual, your brain should be thinking residual equals observed minus predicted. And you want to commit that to memory right now. All right, if you want to use symbols, it's y minus y hat, if you would like to use symbols. So when it says, what's the residual for this 0.47, immediately I'm putting 7 in the observed value, because 7 is the observed y value. How do I find the predicted y value? You plug in 4, which is your x, into the model. So you plug in 4 into the model. So if you have your calculator, you can plug in 4 into that model. And what does the model predict the y value will be for an x value of 4? Great, thank you, Jarvis. That's what I wrote down. I would love to know the answer for that. What is it? 4.22. Anyone can confirm, Catherine? Yes? 4422? Okay, so if I do minus 4.22, it's all good. That will be the answer, which is 2.78. All right, let's see how we did on the side. Okay, 3 out of 5 groups out that one, right? All right. At least you're on the board for groups DDBJ and DGLE. Still waiting for our first one, those middle ones. And then, Commanding lead now, 2 right out of 2 problems. Okay. Any questions before I go on to number 3? The key thing to remember from number 2 is to memorize this equation. Memorize that. Commit it to memory. Okay, number 3. Number 3 says the correlation between 2 scores, these data values, x and y, equals 0.8. So R is 0.8, which it doesn't ask this, but 0.8 is, that's strong. It's like on the edge of strong, but I'd say it's strong. If both the x scores and the y scores are converted to z scores, then the correlation between the z scores for x and the z scores and y would also be 0.8. Now, it's been a while since we talked about this, but when Desmos calculates R, it's actually using z-scores. So whenever you do anything, if you're talking about doing something with z-scores, the z-scores don't change. And by proxy, the correlation coefficient does not change. So it is E. Uh-oh, look at that. That group is 3 for 3. Commanding lead. Okay, maybe they'll falter as we go on. I'm very chill. I'm so chill, I'm a lemon chill. Remember those? Remember lemon chills? So good. You know how lemon chill? Oh my gosh, you haven't lived. Okay, number 4.
Yeah, we haven't lived.
Okay, another least squares regression line that's looking at the weights in pounds of young children and their age in months. Now notice it has y hat says the predicted weight. So that's a predicted weight. And t is for the age in months. So you don't have to write this. I just write that for myself to help me know the variable names. You guys know that when I write these linear regression models, I never use variables x and y. I always use the names of the variables, which I encourage you to do as well. That will help you out on the test on Thursday. Oh, I don't know, but it says, residual again. So residual, observed minus predicted. So immediately, it tells me that a 20-month-old child, 20 months, so again, a 1-year-old child, has an actual weight of 25 pounds. That is the observed weight. When it says actual, that's the observed weight, right? When the child goes to the doctor, they weigh the child, that's what they observe. Now, this model can spit out a prediction for how much we expect this child to weigh, just based on their age. That's it. All right. So in this case, I'm going to plug in 20 where it says age. It's going to be 16.6 plus 0.65 times 20. All right. So it's going to be 20 times 0.65. So times 10 will be 6.5. Double that, and you get 13. So 16.6 plus 13 is 0.6. So you put that in the predicted. And when you subtract that, you get negative 4.6. Or B. Are you okay? What? So 4 is B. Hey, good job. DGLE. Is that you guys? Well done. Good job, Edgar. So what happened? Wenceslas, you were like really mad about this. Oh, you put pot. Oh yeah, everyone put C. Look at that. Good job. Good eye there, Wenceslas and Jarvis. If you look at. Okay. if you look over the groups that missed number 4, you can see everyone picked C. You okay? Okay. And C is positive 4.6, so maybe you just switch the order. So it's always observed minus predicted. Always. Commit it to memory. Commit it. It's going to be there. Pretty good? I'm hoping that as we're doing these, that you see that you can do this. Right? I'm really hoping you can. All right. Number 5. They must really love crickets, because these are from actual AP exams. Obviously, these are different years. But look, the chirps of the crickets are back. But this time they've switched it. All right? They've switched the X and the Y. This time, the Y is the chirps per minute for crickets. So I'm going to write chirps hat equals 10.53 plus 3.41 times, and X is the number of degrees in Fahrenheit by which the temperature exceeds 50. So I'll put temp above 50 degrees. Say it again. Yeah, so like anything that exceeds. So if I put 1, this is a good thing to listen to. If I put 1 here in these parentheses, that's really 51 degrees Fahrenheit. Everybody see that? Because it's like, okay, what's 50? And then what's your number? Subtract out 50. Right, so if you're looking at 40 degrees, you would have plugged in negative 10. Because 40 degrees Fahrenheit is 10 below 50 degrees. Just something to keep in mind. I don't think that actually affects how you do the problem, but it's just something that could come up on the exam on Thursday. Okay, so it says to look at the slope and tell us what the best meaning of it is. So immediately, all I care about is answers that have something with this number in it. So not that one, not that one. And the slope has no meaning because the units, I never talked about that. Your X and Y most likely won't have the same units. It's all good. So really, the moment I look at the slope, I've already narrowed it down to, it's a coin flip, 50-50. Okay? So the question is, how I would phrase it is, for every increase in my temperature by 1 degree over 50 degrees, I expect the number of chirps to increase by 3.41, which is B. All right, let's see how we did there. 5 was B. Nice. Got that one, got that one, got that one, got that one. Oh, so close. You guys are the only team to get the last one right, but the only team to get this one wrong. So you give it right back. Sad. Okay. We're halfway through. How are we doing?
Pretty good. Pretty good.
So we have 2 right, 2 right, 2 right, 4 right, 2 right. We're going to stay. Just give it to you? No, that's not how it works. Remember, you're trying to get half right on Thursday. Trying to get half right. That's the goal. Half right. Half is a 70. All right, number 6. Number 6. All right. Now this is talking about the relationship between the amount of caffeine that a rat consumes and the blood pressure in that rat is Y. So it says R is 0.428. So that's a moderate linear relationship between these. It's not weak, it's not strong, somewhere in the middle. I haven't talked to you about anything to do with the population. So you should have crossed that A because I've never actually said the word population yet. On purpose. I won't talk about that until next unit. So you should have crossed that A immediately. Great, no one put A, so that's good. If the rat stopped drinking the water caffeine mixture, this would cause a reduction in the blood pressure. It probably would, but you're assuming what? You're assuming cause and effect. Right? Correlation does not mean causation, so I can't assume that that's true. C is interesting. About 18% of the variation in blood pressure can be explained by the linear relationship between blood pressure and caffeine consumed. That sounds like something we've talked about. Anybody know what that is? That's what it is, Liam. It's r squared. So just out of curiosity, those of you that have a calculator, what is 0.428 squared? Because that'd be r squared. Thank you for that. That's why I said those with the calculator. Oh my gosh, it's 18%. So I think that might be it. Let's come back to it. T, rats with lower blood pressure do not like the water caffeine mixture as much as the rats that have the higher blood pressure. I don't know how you know what a rat likes or doesn't, so no. E, since the correlation is not very high, it isn't. The relationship between the amount of caffeine consumed and blood pressure is not linear. That's not what we're saying, though. It can still be linear. It just might be a moderately linear relationship. You're welcome.
So I can use it?
No.
Oh.
Because I was saying moderate in terms of strength, and you were not. You were saying it might be linear. So it's C. 6 is C. Oh no, my green. Where'd my green go? Yes, I said green go. You gonna be okay? What was it? 6 is C? Oh no, did we all get it wrong? Hey! Good job, guys. Well done. All right. You made up some ground. Let's go to 7. All right, 7. Okay, you've got a delivery service, places packages in containers, cool. Okay, they vary in weight, cool. They always have 2 of them on each flight. Shh. Okay, interesting. So when they choose the containers, they always have to look at their combined weight that doesn't exceed a limit. Let's say like 100 pounds. Okay? All right, interesting. So if I were to sketch a scatter plot where this is package A and this is package B, let's say this package I'm looking at is 90 pounds for A. 90 pounds for A. So it'd be like, how much for B? 10. So it'd be like down here, right? So 90 for A, but only 10 for B. What if I had a package for B that was 90? Then A would need to be 10. So you're going to see that it's going to create a linear negative correlation. All right, so 7 is B. Oh no! Oh no! All right, what do we put? C and E? So C says a correlation that's less than 1, but it says positive. So this is going to be a negative R because the slope is negative. So R would have to be a negative number. So that's why it's not C. And then E cannot be determined. Bold to go for that. I don't think we've ever had one yet that says cannot be determined. It can be determined if you know how to make a scatter plot. All right. Yeah. Did I not do a good enough job explaining? Well, okay, so do you understand? I made up a number. Yeah. Because it said a weight limit. So I made up a weight limit. 100 pounds. So if I pick up a package, and that's package A, probably shouldn't if it's 90 pounds, I weigh a lot. So 90 pounds is way over here for A. And so B can only be 10 pounds, so it's barely up at all. That's why the point is here. So this is 90, 10. And this one is 10, 90. So if you want to pick this one, it's 50, 50. This one is 30, 70. This one is 70, 30. And I just put all the dots because it's not going to be perfect like that. It could be like 65, 35. Yeah, you could switch it, man. Let's switch it. You want to switch it? Okay, so you said B was 90, right, on this one. A is 90, so if I switch it and make it 1090, well, it's just going to be, it's going to switch those points. But it's still going to be Negative. Right? If one gets bigger, what happens to the other package? It gets smaller. Right? If one goes up and the other goes down like this, they have a negative relationship. Okay? That's all that's saying. So I'm not sure if that answered your question, Liam. Yeah, okay. Sounds good. Yeah, let's do it.
Do you know, like, how do you order something like the outlier or more dots that are?
There could be. I don't know. Well, what would you make an outlier if they have to be 100? Is 100 0 your outlier? Then 100 0 is going to be here, right? And 0 100. I'm sorry? I made up the 100, but if you make up 400, then 400 0 0 400. I don't know. That's why I put these. Yeah, I know that if I pick up a package and it weighs a certain amount and it weighs a lot, then the other one has to weigh a little. If I pick up a package like, wow, this is really light, then the other package I better get is going to be heavy. Right? That is an inverse relationship. Ah, there it is. Liam had it. Right? That moment, right? Ah. So to answer your question, I mean, I don't know. Like, do you really need to do this to get the answer? No. But I think it's helpful to see a visual personally. Okay. Number 8. Did I mark off 7? Yeah, because we all got it wrong. That's right.
Who got the right answer?
For 8, let's see. Which of the following scatter plots could represent a data with a correlation coefficient of r equals -1? Guys, that is a perfectly negative line.
Only one.
Did we all get it right? Hey, good job, guys. Woo! Oh, man, that was fun.
Square.
30 minutes left in class. All right. Let's go number 9.
This one was hard.
Was this one hard? It was a lot of reading, right? Most students, when they see all that, those words, like, oh my gosh. Right? Remember, I told you guys, stats is really just a reading course. Here we go. Okay, so they're basically asking couples to rate how it is to live in their town. Okay? So the first thing I notice, I actually don't notice that first, but you could if you want to describe it. I would say it's curved, positive, and
Moderately.
I mean it says R is almost 0.8, but it's curved, so I don't really care about R, right? But what I do see is that the husband's, I mean, can you just respect it for like a few more minutes, right? I'm almost done, and then you can talk to each other, okay? And in college, if you want to do that, just leave, right? You don't need to be at a lecture if you're not going to listen. So, you see the husband, the lowest rating for the husband is this point here, 4, or 4.3, comma, what, 2.2? Just made it up.
That's when you said that it affects the other.
What affects it?
That 1 point.
That 1 point? Yeah, if I take it out, it's going to change. But right now, I just want to show you that the lowest rating for the husband is above 4. But look at the wife. The lowest rating for the wife is 2.2. And look at all these other points. That's like 2.8, 2.9, 2.95, 3. There's a lot of wives that are rating it below 4. But are any of the husbands rating living in their town below 4? No. So that's a thought. If you need to write it down, write it down. But that's the first thing I noticed. So let's read it. Husbands tend to rate the quality of living higher than their wives did. That's literally what we just talked about. Let's check B. More overall ratings of 7 or less were assigned by the husbands than by the wives. I think they got that flipped. When you look at 7 or less, who's assigning more for 7 or less? The wives. The wives are basically saying they don't like living in their town as much as the husbands. So no. The range in the husband's overall ratings is greater than the range in the wives. The lowest husband one is 4.3. What's the highest husband one? 9. 9 minus 4.3 is less than 5. What about the highest wife? 8.7. But the lowest for the wife is 2.2. That's a larger range. So they got that wrong as well. The range is bigger for the wives. C. The difference in overall ratings between a husband and wife was not more than 3 for any couple. Can you find a point that has more than 3 difference? Bingo. Look at that point. Almost an 8. Less than a 4. You subtract 8 and 4 and you get 4. And so when it says no more than 3, that one was more than 3. Almost there. E. For each couple, the overall rating assigned by the husband was the same as that assigned by the wife. I just showed you the very first point. They did not assign the same rating. So A it is.
Good job.
Ah!
Got them already.
Did we? Oh, not the last group.
Y'all seem to get all the hard ones, right?
Well, they all count the same, right?
Good.
Do you guys see why C is wrong?
Yeah. Yes, sir.
All right, last one. And this one is probably the most important one to listen to because I go over how to use computer output to write a linear regression equation, which for sure is going to be on the test. So you definitely want to take out your pencil if you haven't been doing things and write this down. So we have computer output to predict tail length. So the first thing I write down when I see that is tail length hat. When I see the word predict and a variable name, I write down the variable name with the hat. Equals. What is the constant? You see the constant here? That constant is my y-intercept. Always, the coefficient for the constant will always be the y-intercept. No, I'm not going to get there yet. That's in second semester. So really, when you're looking at this does not matter for our purposes right now. It will come into play next semester. Yeah.
So where does he at right now and cross it out?
Yeah, you don't need it. But do you know how to write the equation from this? That's what I'm teaching you right now. Because you will need to do that on Thursday for the test. All right. Do you see how the next coefficient is positive? So plus that 0.5264 is called the what? The slope. This is the slope. The coefficient for the one that has a name that's not constant. See how it says total length and not constant? That one is always the slope. The slope. All right, times total length. I'm never going to write x. I'm always going to write the variables. So I want to pause here, and if you have questions, now would be the time to ask, because you will have to do this Thursday for a grade. Yes. Correct. So when I look at this output, I'm always looking for the word constant. Whatever coefficient shows up for constant is the y-intercept. Yeah, maybe it says scores. I don't know, yards, right? Probably not shoes, right? Because we need a quantitative variable. Cheese? No, I'm confused. Yes, it'll say something different. So you just put something different right there. Okay, so based on the residual, I see the word residual again. Observed minus predicted. If you haven't been convinced by now, I'm not sure what else to tell you. That was 3 problems where we've used this formula out of 10. Okay? It says, suppose a roadrunner has a total length of 59 centimeters. All right? Total length is my x. But that's not any of my y values. And tail length of 31.1 centimeters. That's my observed data value. It's not what I plug in, but that's what I put into my observed value for my equation. If you want to say plug into this equation, that's fine. I just don't want you to think you're plugging that into the model. You're going to plug in the 59 into the model. So this 59, where it says total length of 59 centimeters, that's replacing total length. So you're going to write negative 1.281 plus 0.5264 times 59 centimeters. And if you guys could use your calculator to get that. Don't worry, Leslie, I'm going to download this and upload it with the video so you can see the notes too. Can anyone confirm with 29.8, I think is what I heard?
Yeah.
right? If I just round. All right, so what is 31.1 minus 29.8? Oh, sad. Didn't think we needed it. 4.3. Yeah, I just thought we could do it mentally. That's okay. Just kidding. So, the first thing I notice is my residual is what? It's positive. So you can go ahead and cross out B and D and E because the residual is not 0. Right? Because those answers say the residual is negative or it's 0, which is not true. The residual is positive. Okay? So if it's positive, we have to ask ourselves, is it an underestimate or an overestimate? So based on the residual, does the model overestimate or underestimate? Well, what's the model saying? It's lower. So the model is actually underestimating.
Dang. Let's go. That's capturing right there. I'll say C.
All right. So if we take a look at our results over here on the side, we would see that this group got 1, 2, 3, 4 right. Remember, you're trying to get 5. 1, 2, 3, 4 right. 1, 2, 3, 4, 5. Hey! 1, 2, 3, 4, 5, 6, 7. Ooh! 1, 2, 3, 4, 5. So our winners, this group here. You get a free point on the test on Thursday. A free point. But remember that free point gets multiplied when I curve it. So it's really more than 1 point. All right? Any questions on number 10?